Okay, I hit a button. Here's the task that I'd like you to do. Okay, everyone see this graph of a line I have here? Does everyone see it? Okay, what is the actual equation of the red line? If I asked you what would the equation of this red line be, can anyone give it to me? Can anyone name anything? Yes, what do you got, Sergio?
Y equals 2, no, y equals x plus 2.
You think this is the line y equals x plus 2. How'd you get that?
The y-intercept is 2.
The y-intercept is 2, good, yep.
And slope is 1 over 1.
And the slope is 1 over 1, up 1 over 1. Do we agree? Is that a good statement? Yeah. So this is the line y equals x plus 2, all right? And then here's what I would like you to do. So I have a graph here, and I have the line y equals x plus 2, and Sergio told us what the equation was. What I want you to do is I want you to find at least 3 coordinates, and a coordinate is just an x and a y, that makes the statement true. And the statement that I'm talking about is this statement right here, the one that I'm highlighting. Y is less than or equal to x plus 2. I want you to find 3 coordinates all by yourself that make that statement true. Everybody understand what I'm asking you to do? I see some head shaking and so on and so forth. Okay, good. We'll give you 1 minute to come up with 3 coordinates. All right. Let's talk about what we've done. Many of you chose points that were on the line, okay? 2 of you, or actually 1 of you, chose some points that were a little bit off the line here. But is this a solution right here?
Yes.
How about this one over here? Is this a solution? Is this a solution? How about this one? Is that a solution too? Is this a solution over here? How about this point? What about that point? How about this point?
No.
Okay, what's different here? Where are all of our answers?
Negative.
On the right side.
All of our answers are on the right side of what? What do you mean the right side? On the right side of the line. Okay, good. Well, how do I know that all of my answers are over here? How do I know that's true? Could I take any one of these points? Like, what? Can I take this point, for example, and say 0, 0? Isn't that the easiest point that's in that region? Right? Do you see how there's 2 separate regions? There's a top part and there's a bottom part. You guys agree with that? The line splits the graph in 2. There's a top and a bottom. So the question is then, like, how do I know where all of the answers are? Well, it looks like all the answers are below this line. So let's take a test point like 0, 0 and see if it's true. Is 0 less than or equal to 0 plus 2? Is 0 less than or equal to 2? That is true. Let's take this point, though, over here. What is the coordinate of that point, you guys? -4, 3. This is the x. This is the y, huh? Let's plug that in. Let's see here. Is 3 less than or equal to -4 plus 2? So is 3 less than or equal to, how much is -4 plus 2? Is 3 smaller than -2? No, this is false, isn't it? So the line divides the graph into what we call a true region and a false region. And we want all the ones that were what? That were true. So it turns out you can take your crayon now and you get to color in all of these points. Any point that is below this line will satisfy the equation y is less than or equal to x. Okay, so continuing in that fashion, here's the next thing I'd like you to do. I'd like you to tell if the ordered pair, and you guys, what's an ordered pair again? What is an ordered pair? A coordinate point, yeah, like an x, y. I'd like you to tell if the ordered pair is a solution. Now, I'm going to give you 2 points, and the points I'm going to give you are 2, 0, and B, the point is going to be 2, -1. And the inequality I want you to take a look at is this. 3x minus 4y greater than 9. Greater than 9. So, please tell me which of those 2 points, A or B, which of those 2 ordered pairs is a solution to our inequality 3x minus 4y is greater than 9. Maybe one is, maybe both are. All right. We got to keep going on here. All right. How do we determine if an ordered pair is a solution to an inequality? What can we do? What's the word what's the mathematical word we're going to use? Yes, sir.
We have to stick in.
Yeah, the stick in. So we're going to use substitute. We're going to substitute. The 2 represents the x, the 0 represents the y. We're going to substitute in 2 for x and a 0 for y. So that means 3 times 2 minus 4 times 0. Is that bigger than 9? That's the question that we have to answer. So is 6 take away 0 bigger than 9? Is 6 greater than 9? Yes or no, you guys? No, it sure isn't, right? That's false. That's false. 6 is not bigger than 9. Filberto, what'd you do for part B? Yes, Filberto, what'd you do? You substituted. Can you tell me what you substituted and where?
2 -1.
Filberto, what do you think, buddy?
Three x.
3x minus 4y, yep, greater than 9. Then what do we do? Can somebody help him out? What do we do now if we have 3x minus 4 is greater?
Oh.
Yes, sir. Yes.
You substitute 2 in for x and 1 in for y.
Exactly. Substitute 2 in for x and 1 in for y. So 3 times 2 minus 4 times negative 1.
Minus 4.
Does that say 6 minus 4?
Oh.
Oh, 6 plus 4. Is that greater than 9? Is 10 greater than 9? Yes, that's true. So what can you then conclude if 10 is greater than 9, and now we have a true statement? What can you conclude about this particular point? It is a solution to this inequality. That's what we're going for today. It is a solution to that inequality. Okay? I'd like to show you something here, if I can. We had this. We had 3x. What was it? Plus 9y, was it? Minus 4y. No. Is greater than 9. Is that what we had? Okay, good. I'd like to graph this. Okay? We're going to graph this over here. Up on my screen. There it is right there. It takes a little while. Okay? Now, what do you notice about this particular graph, you guys? What do you see? Tell me what you see. Lots of dots. But more importantly, where are the dots? They're on the right side of the line. And what point were we testing over here? We were testing these 2 points. We were testing 2, 0 and 2, -1. Let's check this out. Where's the point 2, 0? 2, 0 is right here. Is that in the region? No. Is 2, -1 in the region, though? Yes, it is, right? That's down here in the region. So, can you give me one other point that will make this a true statement? Give me any point you want. What? 4, 0. Absolutely right. Give me another one. 6, 0. 8, 0. 10, 0. Any others? Can you give me another one that's not on the x-axis? 10, 4. Ooh, 10, 4. Yep. Any others? Good. Yeah, it seems like you got it. Here's a question for you, though. What do you notice about this particular line, the red line here? It's red. Yes, we got that. But what about the shape of it? It's not a whole line. It's dashed. Why is it dashed, do you wonder? Because it's not equal to. So points on that line don't count because it's not equal to. Whereas the very first one that we saw did, right? Those were equal to. Yes, sir. Okay, so the first thing we have to do is we're going to have to create a coordinate plane on our graph paper. So please take your ruler and create a coordinate plane on your graph paper. Four, yes, good. The y-intercept is 4, so we're going to go up to 4. 1, 2, 3, 4. What's the slope of this line? Is it positive 1/2 or negative 1/2? It's negative 1/2. How do I write the slope in on the graph? What do I do to draw it? Go down, and then what? 1, how much over? Go down 1 over 2. Now, the line says, is the line solid or is the line dashed? Can someone say why it's dashed? because it doesn't have less than or equal to. So I'm going to have a dashed line here. So you guys have rulers, so it'll look a lot nicer on yours, but this is basically what I'm going to get from mine for drawing freehand. Okay, the question is, do we shade above this dotted line or do we shade below this dotted line? And how do you know? You get a point. Which point would you like to get? 0, 0. Oh, that's a great point. That's the easiest point to check, isn't it? Now you're thinking. Let's plug in 0, 0. So let's figure it out. Is 0 less than negative 1/2 times 0 plus 4? Is 0 less than 4? Is that true or false? That is true, isn't it? That is definitely true. So it seems like all the points that are below this line make it true. Let's just double check it, and let's pick a point over here and see if it comes out false. What point is this that I just created? 1, 2, 3. 3, 5. Okay, good. How can I test to see if this makes it false? What do I do? Substitute. Yes. So 5. Is 5 less than negative 1/2 of 3 plus 4? Is 5 less than negative 3/2 plus 4?
Yes.
No.
Wait, no.
No, right? Because this says that 5 is less than 4 plus or 4 minus 1.5. What's 4 minus 1.5?
3.5. No, 2.5.
Is 5 less than 2.5? That is false, isn't it? So that means that we're going to shade, so we're going to take our crayon and we're going to shade everything that is below this line. So we found the true region here. So we want everything that's below that region right there. We're going to graph 2 more inequalities together. The first one I'm just going to say x is greater than or equal to 3. So I'm going to draw a coordinate plane on my graph paper. And I'm going to make little marks to represent certain lines. And I think I need to make this a little bit longer here. Here we go. Which axis is the x-axis? Which axis is the x-axis? The horizontal one, yes. Which one's the y-axis? The vertical, very good. Okay, which numbers would satisfy the inequality x is greater than or equal to 3? Give me a number that would work. Would 3 work? Is 3 greater than or equal to 3? Okay, give me another number. 5. Yes, would that work? Is 5 greater than 3? Yep. 4, yep. 8, good. What about this point over here? Would that point work? Why would that point work? What's the coordinate of that point? 5 comma what? 5 comma 3. Which one's the x? The 5 or the 3? The 5, right? Which one's the y? And we want only x values that are greater than it. So is 5 bigger than 3? Is 5 bigger than 3? Yes. Yes, good. So, okay. Yeah. All right, so where is the line x is greater than or equal to 3? Is it vertical or horizontal? Is the line x greater than 3? Is it vertical or horizontal? Vertical, yes, it's vertical. And is the line solid or dashed? Solid. Why is it solid? Because it has the equal to sign. So we want everything that's over in this section of the graph here. We want all this information here. All the way up to that line. How about this point over here? Will this point work? No, why not? Because it's false. Yeah, it's not on the right side. Okay, there's 5 minutes left. We have one more to do, and it's the most challenging. We're going to graph this one. 2x plus 4y is bigger than 8. 2x plus 4y is bigger than 8. What's the y-intercept of that line? Is it 4? How do you know? It's 4? Are you sure?
Yes.
How do you know the y-intercept is 4?
It's
It's
A.
8.
Yeah.
Uh-oh, we're all over the map here. Does this look like this?
Nope.
Does that look like that? No.
And get Y by itself.
Gotta get y by itself. What can we do?
-2.
We can subtract 2x. Yeah, very good. So that would give us 4y is greater than negative 2x plus 8. Am I done yet? Divide by 4. Great. Nice job. So y is greater than negative 1/2 x plus, how much is that now? 2? So what's the y-intercept? Oh, it's 2, so okay. So the y-intercept you said is 2, so I'm going to go up to 2. Good. Then what am I going to do? Down 1 and over how much? Down 1 over 2. Yes, very good. Is my line solid or dashed? Dashed. Why is it dashed? Now, do I shade above the line or below the line? We don't know yet. Okay, what can we do? Take a point. Which point would you like to test? 0, 0. It's the easiest one out there. Let's test 0, 0. So let's plug in. Is 0 greater than negative 1/2 times 0 plus 2? Is 0 greater than 2? That's false, isn't it? So, if it's false, which way do I shade? Shade the top. Very good. So we want all this information here.